Welcome to this session where we'll be discussing about medical diagnosis, the treatments, the issues in medical diagnosis, and how computers, computing methods, and artificial intelligence in specific solves many of these issues. So the task of medical diagnosis, like any other diagnostic process, is made more complex because of a lot of imprecision that is involved in the process. Moreover, patients may not be able to describe exactly what has happened to them or how they feel. The doctors and the other healthcare practitioners may not be able to understand or interpret what the patients say exactly. They may know what they are telling, but they will not know the amount to which the degree of their expression cannot be clearly captured by the doctor. And adding on to all this, the laboratory reports are not instantaneous and may come with some degree of error. They may be observational errors or data entry errors, or so many kinds of errors are there. And medical researchers cannot precisely characterize how diseases alter the normal functioning of the body. So such issues exist in medical diagnosis and treatment. And a number of medical expert technology oriented systems have attempted to mitigate these challenges all over the years and have attempted to address the subjects of knowledge acquisition, representation, and utilization in medical diagnosis. However, the problem of managing imprecise knowledge still exists. The uncertainty, the ambiguity that exists in the diagnostic process and the decision making process are still yet to be improved and resolved. Clinical decisions about systems utilize patient's data and some inference procedures like Bayesian's theorem or inference mechanism or some form of intelligent inference mechanisms to generate case-specific advices and suggestions to the practitioner. So the process of disease diagnosis and management is complex because of the numerous variables involved in the process. In the variables, I mean the features, the symptoms, or it may be the environmental conditions. So what we call as features in machine learning or attributes, or dimensions in the case of a data set, that's what I mean by variables. It is further complicated by the imprecision and uncertainty associated with such variables, right? So unacceptable morbidity and mortality rates are still recorded in developing countries where systems in deployed are not up to the mark or up to the state of art level. Since the effectiveness of the therapy for a given disease is highly dependent on the level of accuracy of its diagnosis, this complexity in medical practice makes the conventional quantitative diagnosis approaches inadequate, and hence all calls necessity for new methods of diagnosis is very essential. So that's where artificial intelligence comes into the scenario. Computer tools help us to organize, store, and retrieve appropriate medical knowledge needed by medical practitioners to deal with different difficult cases and suggest appropriate diagnosis, prognosis, and therapeutic decisions. Now, let me give you an insight about the things that are happening currently. Human coronaviruses, HCOVs in short, or human coronaviruses, were considered to be a minor pathogens causing the common cold once. And these viruses are also ecologically diverse with some assortments seen in animals, specifically in bats. You know, these birds that fly in the night. So, people affected by coronavirus often manifest with significant respiratory disorders and lung diseases that contributed to clinical morbidity and mortality. But this is all about the common cold. But what happened in course of time? Severe acute respiratory syndrome coronavirus, or it's called as the SARS-CoV. Now we had an epidemic called SARS epidemic, right? So and the Middle East respiratory syndrome coronavirus, MERS-CoV, these two are also coronaviruses that were highly pathogenic and were the cause for high death rates in the 21st century. Both the viruses were from animal farms and were global epidemics or pandemics. And in December 2019, yet another pathogenic human coronavirus, 2019 novel COVID or coronavirus COVID-19, was recognized in Wuhan, China, and has caused serious illness and death. This was first reported in China with 41 cases, and in which 66% of the patients had a history of exposure to human seafood market that is in Wuhan. So coronavirus with other respiratory disorders were also diagnosed. The course of this pandemic was still remains impossible to track. And this situation, timely development and implementation of effective countermeasures are very much essential at this point of time. When there were disease outbreaks, people panic and rush to nearby hospitals, even if they get a common cold during these times. Even if someone coughs in the next house, like we are very much afraid, and we think that someone is having a corona symptom, and we try to refrain ourselves from them, and many other things like that. So this may result in denial of service and medical administration to true victims, because those who actually have the coronavirus are not able to be treated in the place where many others with similar symptoms like respiratory disorders or coughs or just normal headaches go and land up into hospitals, and because of them being treated, the real patients who need to be treated are denied of treatment. Having this said, let me go and give you a brief insight about how India had scored during the past virus or viral outbreaks during the past days. The human immunodeficiency virus, which we popularly call it as the HIV, is supposed to have entered India in 1984, right? It was not a modest public infrastructure system at that time. You can imagine 1984. And the lack of awareness was clearly felt, while other countries were good at tracking this epidemic. And the Nipah virus remained undiagnosed until there were 66 cases and 48 deaths. Until then, India remained dormant during the outbreak in 2001 at West Bengal. Nipah was in due course diagnosed by researchers in the US in 2006. And there were many other more Nipah outbreaks, 2007 in West Bengal, 2018 in Kerala. However, were quickly traced and controlled, because once they came to know of the situation, we were able to bring it under control. But it can be observed that outbreaks of a similar virus or viral infections may occur again over a period of time. Hence, public health services and citizens too need to be watchful at all times. The outbreak of severe acute respiratory symptom SARS was first felt in China in late 2002. All nations fought SARS based on WHO framework that was focused on WHO's influenza pandemic preparedness plan, whereby the spread of SARS coronavirus was interrupted by mid 2003. It was indeed a good plan and charted out well, and it worked out well too. However, 27 countries were affected with more than 8,000 cases and 750 casualties. But considering the current scenario, this was not a big deal. The fatality rate was 9.6%. In 2009, India effectively attempted to prevent the onset and manifestation of the pandemic influenza HI1 in screening all arrivals at airports. However, it had a quick spell and it was felt wide. The countermeasures adopted for SARS were applied then, but it was of less avail for the flu. Health centers were not equipped properly, and testing facilities were lacking. Thereby, the patients who went to clinics and health centers were not diagnosed properly, and the situation was not managed efficiently. Most actions and responses were reactively and ad hoc, were not in a planned manner, whereby clearly pinpointed the lack of public health administration efficiency. So when these viruses, pandemics and epidemics came into picture, if we had properly planned and how to use our hospital resources in these situations, then we would have not ended up in such a pathetic situation as we are now. So the characteristics of the coronavirus 2019 COVID that causes the COVID-19 disease is closer to the pandemic that happened before, like the HIV or the seasonal flu, rather than the SARS that was eliminated quickly. This cannot be suppressed by just screening of passengers at airports or at public places or normal people at several screening points. Like the H1N1 coronavirus can escape detection in spite of screening. There may arise a fresh wave of attack even after the lockdowns and curfews. The case fatality rate in India needs to be monitored well. If the standard of care is not good as in other countries, our fatality rate may also go higher as we experienced during the past outbreaks. So most district hospitals, however, do not yet have an influenza diagnosis facility. If the coronavirus infection reaches an unexpected place, then obviously a cluster may break out and before the diagnosis is established. Then it will be even more difficult or even impossible to trace and track all persons in that locality who are in contact and with all the infections and infected individuals in that area. Hence, universal healthcare and public health systems that are readily reachable and also affordable needs to be developed. So, what I intend to say is AI and all these developments in technology should be infused with this current issues in medical scenario so that you know that healthcare is a right of every citizen and every case of respiratory disease syndrome or any disease outbreak or for that matter any severe illness like encephalitis or even in the most remote villages deserves diagnosis by laboratory methods. Those of you who would have watched my previous videos will be much familiar with this machine learning or AI cycle which I have shown over here. So it consists of initial data acquisition phase, then a feature processing phase, and then some kind of machine learning algorithm works, and then from that inference we apply some of in the previous work we applied some soft computing approaches and fuzzy logic based approaches. Here we will be applying some of the AI based or explainable AI paradigms whereby we will be able to give some justification to the clinician who is using the system. So this kind of a cycle is very common in the machine learning literature, but differs in many modules or in the way the modules are implemented, the techniques used in each and every other phase may differ. So let me give an insight about how this is going to fit in for the coronavirus situation now, or how AI and AI based techniques can be used for tracking respiratory disorders and viral disorders. So firstly, we get into the data acquisition phase. There are many well-known ML repositories or data repositories such as the University of California, Irvine, UCI dataset, Kiel dataset, Kaggle dataset, OGD, and many other public datasets on respiratory disorders, kidney disorders, lung, liver and heart disease, cancer. Many more datasets are there, and and now much more have emerged due to studies conducted by researchers across the globe due to the outbreak of COVID-19. These datasets are annotated based on patient state, hospital discharge records, or expert opinions. However, these data sets can be used by machine learning approaches for generating knowledge models for a specific disease such as asthma, SARS-CoV, or COVID-19, or any disease for which the dataset is designed or obtained from. The input data will be obtained from the patients by healthcare workers and clinicians. So people will be interviewed, the patients will be interviewed from the by the healthcare workers or the nurses or the people at the point of care, and details about their geographical locality, environmental conditions, health status of their family members, and finally the symptoms the patient encountered will also be recorded. The recorded details include a list of drugs they take or the food they eat, their body temperatures, physical symptoms, family history, body temperature, blood pressure, glucose levels, and other laboratory based tests which you do in the lab may also be incorporated with this data. So, based on this and based on previous medical consultations of the patients, laboratory tests will be performed, or maybe other sophisticated tests like ECG or higher level of testing may be also performed, scans, and many others. The observations of the lab test will be appended to the patient's record, and these records are stored in forms of EHR, or electronic health records, or electronic medical records, or EMR, for future purpose in different formats. That's easily accessible to the patients and also to the clinicians and also to the health center workers or wherever they are needed. After integrating all the above data from various sources, we need to have an eye on the quality of the data, how the data is, whether the data is sparse or inconsistent, or is it noisy, and about the different scales of different features may vary significantly. All these things need to be considered. So data quality and its accessibility are the two main factors where that needs to be addressed when designing a machine learning pipeline. So cleaning will help in getting much efficient data. So when we have good amount of data and also clean and quality data at the initial stages of data mining, definitely the knowledge discovery process or the machine learning process at the end will fare better. So the process of cleaning includes one or more of its trivial approaches such as Z-score normalization, quantile normalization, binning, double exponential smoothing for temporal features, and usage of appropriate measures of central tendency like mean, variance, standard deviation. So we need to know what to apply where, whether it is very essential, right? So when to apply a geometric mean, when to apply a harmonic mean, when to apply a normal arithmetic mean. All these kind of things, though it may seem to be very minor things, but these subtle differences in the application of techniques will lead to huge difference in the results that we obtain. Moreover, cleaning may also require knowledge from which the doctors or clinicians may be involved in the process. We need some amount of domain knowledge too to clean the data and make it better or more relevant to the scientific application. Data cleaning may also require sampling approaches in case there exists imbalance in the data. If needed, similarity, minority, or sampling techniques like SMORT, borderline SMORT, and many variations of data sampling and its extensions may also be used. So after data acquisition and data cleaning, it's about feature selection. In feature selection, our dimensional detection takes place by using filter approaches such as statistical tests or Z-test or correlation analysis or entropy-based ranking methods such as information gain can be used. So lasso regression and other hybrid approaches may be used if the number of features needs to be reduced significantly. Even by using domain knowledge, the features that are not related or the symptoms that are not required can be removed. So again, there opinion plays a major role. Segmentation of features with result in feature groups such as inhalants or the food habits or the symptoms or similar geographical locations may also be incorporated into the study. So segregation will enable us to implement different classifiers and learning mechanisms accordingly can be implemented so that ensemble methods may be used efficiently to classify samples rather than using single methods. Okay. So classifier ensemble attempts to develop disease specific predictions or predictive models using machine learning and other soft computing approaches. Some of the approaches that generally I use in my works are like multinomial logistic regression or combined with PCA. This may result in an increase in the likelihood of the model, which will make the classification more specific and more sensible too. Then use of support vector machines, use of appropriate kernel methods in that, and optimization of the margins will result in pretty good classifier models. And naive-based approaches for where we use kind of a probabilistic reasoning approaches helps in building some baseline comparisons where because Bayesian classifiers are generally used as a baseline classifier by which we can compare other classification approaches. ADA boosting helps in finding strong classifiers. ADA boosting converts multiple weak classifiers into a single enhanced classifier, which will thereby result in an increase not only in accuracy but also in the sensitivity of the reports generated. The features for which the domains of values is numerical may be given to a fuzzy system like Mamdani fuzzy inference system, FS, which we call it in short. You would have seen in that diagram, right? The features will be falsified using trivial falsification values such as triangular fuzzy functions or Gaussian fuzzy functions or trapezoidal fuzzy functions. Then after falsifications, the rules for the fuzzy inference system based on the features used in the system would be obtained from clinical experts or from health centers or from government hospitals. If the rules are not available from a clinical expert, then you can use some machine learning approaches like decision trees or some categorical machine learning procedures for generating these rules, and these rules may be fed into the fuzzy inference system, which will enable the inference system to get a better understanding of how the falsified values can be mapped to the output values. So use of many classifiers and evaluating each and every classifier's result with their evaluation matrix, and additionally using inference mechanisms for resolving ambiguities will provide a better consensus. So this new one over here, this prognosis mapper, after classification of data, a report will be generated. The report which is generated in this phase is not the final report, right? So, but it is actually the diagnosis. So the diagnosis is on a statistical evidence, whereas prognosis is more of assumptions. So that's the difference between the diagnosis and the prognosis. So diagnosis is evidence, and the prognosis is a kind of a guesswork, or is based on assumptions. So if the in the prognosis mapper, the diagnostic report will be mapped or supported with expert knowledge and with existing scientific literature, which are already available in the databases, scientific databases. So finally, coming to the consolidation and reporting phase, this module takes all the alternatives and choices into consideration and will generate a final concise report that is essential and available to the patient, the clinician, and also to the remote if someone is diagnosing or supervising from a remote location. So the final report will be integrated with XAI techniques or explainable artificial intelligence frameworks to enable the system to develop interpretable and inclusive decisions, and this will enable the clinicians to deploy them with confidence, so that when a patient asks for the reason for their sickness, or the reason not for the sickness, a reason for their decisions, the clinicians will be able to give out the decisions, because the system will not only give the decisions but also the explanation of why that decision came out, why that decision alternative was chosen. So the final report will be made available to the patient through a smartphone or email, as you see in the figure, right? So these reports are also attached to patient's data and will be stored in our database. So by this, maintenance of patient records will be made easy, and the records will be made available to both for the doctors for future investigation and for the patients as a history in their personal medical records. And that's it. Hope this was informative, and thanks for watching.